Good morning, students. Today we will start with our next progression, and it is called geometric progression, or in short, we call it GP also. So, I will start with one simple example. You know, if I have a sequence like this, let us say 3, 9, 27, 81, up to so on. When I am writing this sequence, okay, the first thing that I will think that is it coming like by adding some constant number, or coming by means subtracting by some constant number, or how the progression is there, means how the what is the pattern in the given sequence, right? But here 3, then the next number is 9. So if I say 3 plus 6 is 9, but then 9 plus 6 is not 27, 27 plus 6 is not 81, and so on. So here what is happening, the numbers are not increasing, arithmetically. That means they are not increasing by adding or subtracting some number. But if I do 3 into 3 is 9, 9 into 3 is 27. So how I am getting, it is 3. Then 3 into 3 I am doing, and we are getting number 9. And then this 9 multiplied by 3 when I am doing, we are getting 27. And then 27 into 3 if I am doing, then we are getting 81, and so on. Okay, so what is happening here, one constant number 3 we are multiplying with the first term, and we are getting the second term. So the first term 3 I am getting, second term I am getting by multiplying the first term with 3, the third term I am getting by multiplying the second term by 3, and the fourth term I am getting by multiplying the third term by 3. Okay, so here no addition subtraction is there, but multiplication is there. And in case instead of multiplication we can have even division also. I can have the next term by dividing the previous term by some constant number also. Okay, so the number which we are multiplying, right, to get the next term, okay, so that number here, instead of common difference, what do we have? We have here common ratio. Okay, so this is the common ratio, and the sequence with which number it is starting, a1, this I will call as the first term. As we know, the sequence first number with which it is starting is the first term only. So here our a1 is the first term. This is the common ratio 3. Now a2 is getting means the third term we are getting by multiplying the second term with 3. Okay, and what is this a1? A1 is actually a into 3. So it will be a into a into 3 means 3 into 3 also I can say. So 3 is multiplied twice also I can say. I will show you what I am trying to say here. So first term common ratio. Now here, as we know, in arithmetic progression AP, we said the common difference D is there. So here common ratio I will represent by R, and the first term we will represent by A. Okay, now the same sequence if I write down, it is 3, then 3 into 3, then 3 into 3 square. Okay, and the next term is coming 3 into 3 cube, up to so on. So this is 3, then 9. Okay, 9 into 3 27, 9 into 3 27 into 3 is 81, and so on. Okay, so this 3 is what? This 3 is the first term that I started. So this is A, and this R which I have taken the powers, that I am taking as the common ratio. So the first term is A, second term will be AR, then the third term I will say it will become AR square, and this term we will write AR cube. Okay, so here the first term is 3, and the common ratio is also 3 in this particular example. And how we are writing the terms now, it is 3, then second term 3 into 3, third term 3, that is A into square of 3. So that means the third term is AR square, fourth term will become AR raised to power 3, and so on. So this is our first term, this is our second term, similarly third term and fourth term, and so on. So when I am writing the first term, a is there. So if I want to say what is the power of r in first term, it is 0. In second term, we have a r raised to power 1. In third term, we have a r raised to power 2. So the power of r is one number less than whatever term we are writing. So I can say in general, if I generalize this thing, in general the nth term of GP, I can say it will be a r raised to power n minus 1. So this is how we will write down the nth term of GP. If I know the first term and the common ratio, right, I can write down any term of that particular GP, and that means of that particular sequence. Okay. So this is the nth term formula. And now if I take another example, let us take one more example. We are having here 1 by 5, then it will be 1 by 15, then it will be 1 by 45 up to so on. So here I have the first term 1 by 5. Now how will I check whether it is GP or not? And if it is given it's a GP, how will I find the common ratio? The common ratio we will find by just dividing the second term by the first term. So it is 1 divided by 15 divided by 1 by 5. So it is 1 by 3. That means our common ratio here is 1 by 3. So if I know the common ratio and the first term, so I can write down any term of the given sequence. Okay, and the general term formula is an, means the nth term will be given by a r raised to power n minus 1. Okay, we can have here negative signs also, and we can have here positive signs also, right? So this will be our GP. Now the next thing, I know now how to find the general term. Now the next question is how we will get the sum of n terms of a GP. So we have formula for that also. Let me give you the formula. So let us discuss sum of n terms of GP. If I have GP AR, AR square, AR cube up to so on, let us say AR is to power n minus 1. So in general when we are writing GP, this is how we will write AR square up to so on, and the nth term it will be AR is to power n minus 1. Now sum formula, it is A 1 minus r raised to power n divided by 1 minus r. This formula we will apply when our common ratio is less than 1, and the other formula is A r raised to power n minus 1 upon r minus 1 when our common ratio is greater than 1. Just to avoid the negative sign here, we can use any formula. So when our common ratio is less than 1, it will be 1 minus r in the denominator. So in the numerator also 1 minus r raised to power n. And when our common ratio is greater than 1, we will be using this formula. So this is the formula to calculate the sum of given GP. So here if I know the first term, the common ratio, and how many terms we have to find the sum, we can easily apply our formula to get the answer, right? So let us start with the exercise now. GP exercise, it is exercise number 9.3. okay, and we are given the first sum. Find 20th and nth terms of the GP. So GP is given to us. So let us start with that. Exercise 9.3. The first sum. We are given here GP, and what is the GP given? It is 5 by 2, then 5 by 4, 5 by 8 up to so on, and we have to find the 20th term and nth term. So we know, we know our nth term formula. What is the nth term formula? An is equals to A r raised to power n minus 1. This is the formula. Now for given GP, we have to find the nth term, that means since GP is given, so we must know the first term, we must know the common ratio, and if I put these two things here, it will become our nth term for that given particular GP. And if I have to find the 20th term, then n will be 20 in the formula. Okay, so let us write down first of all, a is given here 5/2, and in order to find the common ratio, I can do a2 divided by a1. So it is 5/4 divided by 5/2. So it is 1/2. So our common ratio is 1/2. First term is 5/2. We will say therefore nth term is, in place of a we will write down 5/2. In place of r it is 1/2 raised to power n minus 1. Now 5/2 into 1/2 raised to power n minus 1. Both the denominators are same. So if you want, you can club also. It will be 5 into 1/2 raised to power n. So this is our nth term. Okay, and now we can find our 20th term. So it will be 5 into 1/2 raised to power 20. There is no need to calculate the higher power of 20 till 10. If it is, we can do. Otherwise you can leave the answer in the power form also. Okay, so our nth term here will be 5 into 1/2 raised to power n, and the 20th term will become then 5 into 1/2 raised to power 20. Clear? Now in the second sum it is given, find the 12th term of GP whose 8th term is given and the common ratio is 2. So once again, as 8th term we know and the common ratio also we know, so if I put these two values in the 8th term formula, I can easily get the value of the first term, that is a. So let us see how we will be doing it. So in sum number 2 we are given 8th term of GP, it is 192. The common ratio is given 2 and we have to find the 12th term, right? So as nth term formula we know, it is a r raised to power n minus 1. So a8 will be a r raised to power 7. Okay, a8 value we know, r also we know, so we will substitute these values. So it is 192 equals to a into 2 raised to power 7. Okay, so a will be equals to then 192 divided by 2 raised to power 7. So 192 divided by 2 raised to power 7 will be 2 raised to power 5 is 32 into 64 and 120. 64 into 2, yeah, 128. Okay, so the value of a you people can easily calculate, and whatever value of a we are getting, that a if we substitute, so therefore a12 will be a r raised to power 11. Okay, so there we will substitute and we are getting our let us substitute the values to get the answer also. So the value of a we are getting, okay, 192 divided by 128, it will be coming 3/2. So 3/2 and 2 raised to power 11. So I can say it is 1 2 will get cancelled. It will be 3 into 2 raised to power 10. 2 raised to power 10 is 1024. So 3 into 1024, it will be 3072. So our 12th term will be then 3072 will be our answer. Okay, this is the second sum. 8th term is given and common ratio is also given. We are just putting these values in the 8th term formula to get the value of a. That a if we substitute here in the 12th term, now a is calculated, r is already given, so we can easily calculate our answer. Sum number 3, 5th, 8th and 11th term of GP are given. We have to just prove. So what we will do here, you will just write down a5, a8 and a11, and they are given equals to PQS also. So the value of Q, value of P and value of S, we will substitute in the given part and we will see LHS is coming equal to RHS. Okay, so third sum I am leaving for you people. Sum 4 is the 4th term of GP is square of its second term. So let me let me give you the hint for sum number 3 also, then you people will be able to do. It is given fifth term is P. So fifth term according to the formula will be A r raised to power 4, and eighth term is Q. So this will be A r raised to power 7, and 11th term is given S. So this will be A r raised to power 10. So the value of P, Q and S, you will substitute in the given part Q square equals to PS. So in the left hand side you put the values of Q, and even P and S you will substitute separately in the right hand side, and you will find LHS is coming equal to RHS. So this is the hint for third sum. Similarly, let me give you the hint for sum number 4 also. Sum number 4 is the fourth term of GP is square of its second term. So A4 is square of the second term, and first term is minus 3, and the first term A is given minus 3. You have to determine its seventh term. So you have to find A7, right? Now we know the nth term formula is A r raised to power n minus 1. A is already given. So from this given condition, we will find the value of R. Once I know the value of R, I can use A and R to find A7, that means seventh term. So I hope you people will be able to do. Just substitute the value of A4. A4 means it will be AR cube, okay, and A2 will be, so here we will put AR cube, and A2 will be AR square. So when you compare it, you will be able to get the value of A. Sorry, not A, R. Okay. So sum number 5 now. Which term of the following sequence is this? So we are given one sequence, and we have to find the given number, the given next term is which term actually. Okay, very simple sum based upon again nth term formula only. So we are given GP, the given GP is, it is 2, 2 root 2, 4 up to so on, and we have to find which term is 128. So GP is given, so we are supposed to find which term is 128. Now when I have to find which term is this, I will assume let it be the nth term, and then I will find the value of n. Okay, so here first of all we are given the first term is 2, and what will be the common ratio? If I divide the second term by first term, so 2 root 2 divided by 2, our common ratio is 2. Okay, now the next thing, we will take let 128 be nth term. Therefore an is A r raised to power n minus 1, and this is given equals to 128. So 128, the value of A is 2, and the value of R is root 2 n minus 1. So if I shift 2 to the left hand side, we are getting 64 equals to 2 raised to power 1 by 2 whole power n minus 1, because root 2 means 2 raised to power 1 by 2. So I hope everybody knows A raised to power B power C, this will be A raised to power BC by the law of exponent. Same thing we will do, it will be 64 2 raised to power n minus 1 divided by 2. Now here we have 2 raised to power n minus 1, and this n we are supposed to find, it is in the power. So how I will get this value of n? If in the left hand side also I can have the same base with some power, so I can equate the power, and we know 64 we can write down 2 raised to power 6, because 2 raised to power 532 into 2 is 64, and 2 raised to power n minus 1 by 2. So we will compare the powers. It is 6 equals to n minus 1 by 2, which implies n will be equals to 13, right? So 128 term, which term it is? It is the 13th term for the given GP. Likewise, you people can do B and C part of sum number 5 easily. Okay, so here let me repeat, sequence is given, we have to find which term is this. So whenever we have to find which term is this, either it's AP or GP, we will assume let the given term be the nth term, and we will just apply our nth term formula. Okay, so from the GP we are writing the first term, we are writing the common ratio. Now in order to write down the nth term in GP, I just need the value of A and R. So that we know, we will substitute the values by we have applied the law of exponent here, then we compared the powers to get the value of n. Okay, now the next sum number 6 we will discuss. So sum number 6 is, we have to find for what values of x the given numbers are in GP. So we have to find x when minus 2 by 7 comma x comma minus 7 by 2 are in GP. Now when the terms are in GP, the common ratio will be same. Okay, so this is means a necessary and sufficient condition for the given sequence to be GP. If it is GP, the common ratio will be same, and if I find in the sequence there is a common ratio, it means sequence is GP. So we will write down, as given terms are in GP, therefore x divided by minus 2 by 7, this will be equals to minus 7 by 2 divided by x. The common ratio will be same. That means A2 divided by A1, this will be equals to A3 divided by A2. Okay, so when I cross multiply, it is x square coming equals to minus 7 by 2 multiplied by minus 2 by 7, that is 1. So if x square equals to 1, that means the value of x will be plus minus 1. So when x is plus 1 or x is minus 1, then the given sequence, given numbers, not sequence, given three numbers are in GP. Okay, so this was sum number 6. Now sum number 7 to sum number 10, we have not till sum number 10, even sum number 11, we have to find the sum of the given terms. In the sum number 7, we have to find the sum of 20 terms. Then sum numbers 8, 9, 10, we have to find the sum to n terms. And sum number 11, we have to find the sum up to 11 terms. So let us discuss sum number 7 first of all. Sum number 7, the given GP is, it's 0.15, 0.015, 0.0015 up to so on. So we are given 20 terms. That means we have to find actually S20, sum of 20 terms. Okay, now we will write first of all the first term. What is the first term? This is our first term. So A is 0.15. Now we will find the common ratio. It is 0.015 divided by 0.15. So what is coming here? The common ratio will be, so the common ratio is coming 0.1. Now 0.1, it is less than 1. So A we know, R we know, therefore before applying the formula, let me write down the formula. So Sn will be A 1 minus r raised to power n upon 1 minus r. Because our common ratio is less than 1, so we will be using this formula. So based upon this, our S20 will be, the first term A is 0.1615, 1 minus, common ratio is 0.1 power 20, we will keep it as such, whole divided by 1 minus r, so 1 minus 0.1. Okay, 1 minus 0.1 means 0.9, and 0.15 divided by 0.9, it will become 0.6. Okay, so our answer will become then, let me take you to the next page. So our answer S20 will be equals to, so it is becoming 1 minus 0.1 power 20, we will keep as such, whole divided by, it was 0.15 divided by 0.9, 15 into 6. So here we will get 6 as the denominator. So this will be the sum of first 20 terms. Similarly, sum number 8, first term we know, common ratio we will calculate and sum formula we will apply, right? Sum number 9, sum number 10, same way we will be doing. Okay, so when we don't know r is greater than 1 or less than 1, then we are free to use any formula. So no restrictions are there. If the standard value of r, means the value of r is not given in the numerical form, you can apply any formula. I will explain now sum number 11. So sum number 8, 9, 10 I am leaving for you. Same formula we will be applying. Sum number 11 is evaluate summation 2 plus 3 raised to power k, where the value of k varies from 1 to 11. So this is summation sigma, okay, and it means we have to add all these terms, where the first, what are the terms? 2 plus 3 raised to power k. The value of k is varying from 1 to 11. That means I will put the value of k 1, then the next term 2, then 3, up to so on 11. So this is actually equals to 2 plus 3 raised to power 1 plus 2 plus 3 raised to power 2 plus 2 plus 3 raised to power 3, up to so on. The last term will be 2 plus 3 raised to power 11. So sum of 11 terms are there, where in the bracket first term is always 2. Okay, and the second term it is changing or in the form of power, 3 raised to power 1, then 3 raised to power 2, then 3 raised to power 3, up to 3 raised to power 11. But in every bracket the first number, the first term is 2. So 2 is fixed. So how many times 2 has been added? So there are total 11 terms. So 2 has been added 11 times. 2 into 11 is there. Plus we have 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, up to so on 3 raised to power 11. So this is directly, it is 22, no problem. But here the terms are increasing geometrically. The first term is 3, then the second term is 9, then so on. That means when I have to find the sum of these terms, I will be applying here GP sum formula. Okay, so here I am going to write down S11 dash, and this S11 dash I am going to solve separately just for you people. Otherwise we can apply the formula directly also. If you people can do, it's okay. So here for S11, what is the first term? 3. What is the common ratio? 3 square by 3, it is again 3. So S11 will be then a r, now r is 3 and it is greater than 1, so it will become 3 raised to power 11 minus 1 divided by r minus 1, that is 3 minus 1. So Sn we are applying a r raised to power n minus 1 divided by r minus 1, as r is greater than 1. Okay, I have mentioned the formula also. So this is 3 by 2, 3 raised to power 11 minus 1. So this is the value, and this value we will substitute in equation number 1. We will say therefore summation 2 plus 3 raised to power k, where k varies from 1 to 11, is equals to 22 plus 3 by 2 into 3 raised to power 11 minus 1. So this will be our answer. Okay, so remember, whenever we have summation, it means sum of these type of terms, and in here we have k varies from 1 to 11. It can be given in terms of n also. Then the value of n, from which number to which it is varying, that will be given over here. Okay, so this is how we will be doing the sum, and that's it for today. You people can do first 11 sums of exercise 9.3. Okay, so I hope you are finding this topic GP easy. So try to do these sums. Thank you, students.